Let's write a practice exercise 16.10, which is stretch. So we need a method called stretch. It's going to take an integer n as parameter and increase a list of integers by a factor of n, and it's going to replace each integer in the original list with n copies of that list. So let's say we have the following right here. We have a list.stretch and we pass in 3 as our integer. We're going to need 3 of each of the values that are already in the list. We can assume that this linked int list class is already going to be created. We just code inside of it, and we can use this private ListNode front, which stores our list, and it's going to be null for an empty list. Let's start this out with a public void called stretch. We take int n as parameter. Inside of here, let's handle this first case, and that's if n is less than or equal to 0. If n is less than or equal to 0, we just want our list to be empty, so we need to set our front equal to null, and that will result it in being empty because it points to a null. Now we want to run through this list. We want to run through it while we don't have a null value, because remember the end is null. So we'll do while, and before we do this, let's make a variable to store our current front data. We'll do ListNode current is equal to front. Now inside of our while loop, we're going to say while our current does not equal to null, we are going to be inside of here. So this is to run through our entire list. Now we're going to need an inner loop to add the values as many times as n wants us to. So let's make a for loop. For int a is equal to, and I'm going to set this equal to 1, and you'll see why in a second. Int a is equal to 1, a has to be less than n, then we're going to have a plus plus. Now inside of here, we want to set the next value, because remember ListNode current, which is what we're going to be updating, which is equal to our front, it currently has this value and it points to the next value. So we want to set current dot next equal to a new list node. We want a new list node here, and we want that to be our current dot data. So that's going to get the data of whatever this is. And then we also need a pointer to the next thing. So we need to pass in our pointer, which would be current dot next. So again, currently with this right here, if we just use the example that we have previously right here, a is equal to 1. If we have our current dot data, it's going to be grabbing this and then putting it into this next spot and then creating a link for the next one. Now we need to update where our current is pointing, because this current dot next is still pointing in this area. So we want it to move to the next part. So what we need to do is set current equal to current dot next, and that'll put it in the next position. And then we can close this for loop. So if I were to do an example about how all of this worked, when we start at line 4 and we set current equal to our front, that means our front, being 18, is current pointing to it. So current points to 18, and then we have a pointer to the next node. Now when we go into our for loop, we'll say when a is equal to 1, we're setting the current dot next value, so that's going to be the position right here with this arrow, equal to current dot data, and the current data is 18, and we're putting a current dot next, so we're adding a new pointer right here. And then we're going to set current now to equal to this position right here. Current is equal to current dot next. Now when a is equal to 2 right here, we run through this again, current dot next, so this next part right here is equal to current dot data, which is 18, and then we create another pointer like this. And then we say again that current is now equal to 18. When we're done with this, because a is equal to 2, remember int n is going to be 3 for this problem, for this example, we are going to break out of our inner for loop. When we break out of our inner for loop, we don't want current to still be pointing to this 18, because we're going to then continuously copy 18 in here, and we're not going to move forward in our list. Because remember, we have a 7 after this, and then a 4, and so on and so forth. We need to insert inside of here, between the two. So what we need to do is set our current equal to this next value right here, and that's going to be outside of our while loop, so that when we do this again, this whole process can repeat but for the 7. And then when that's done, it'll break out of the 7 part and then go to the 4 part. So hopefully that makes sense. If it doesn't, rewatch it or leave a comment in the description below. So again, we need current to be equal to current.next, but outside of the for loop in the while loop. Let's submit that. Again, if you have any questions, leave them in the comments below. And if you want more Java videos, they're in a playlist below the like button. It'll pass 7 out of 7 tests, and that'll be our exercise 16.10 stretch.